Hello, students. Today we are going to talk about a very interesting topic, the physical properties of diazonium salts. We're going to figure out a bit of a chemical mystery together.
Maybe you have seen this in your school lab. You have a solution in an ice bath. It's perfectly clear, nothing is happening. And the moment you take it out and it starts warming up to room temperature, you see bubbles start to form, a bit like a soft drink. So what is going on here? Well, this simple observation is actually the key to understanding our entire topic today.
You see, the chemicals that cause this are called diazonium salts, and their entire story, you could say all their physical properties, can be explained with just one single word. And understanding this one word is absolutely crucial if you want to use them correctly and, more importantly, safely.
And that one word is instability. Seriously, if you forget everything else from this explainer, please just remember this one thing. Diazonium salts are fundamentally unstable. This single idea explains everything about them. It's the master key.
So, why are they so unstable? What makes them so different? Well, at the most basic level, diazonium salts are ionic compounds. That means they are made of positive and negative ions, just like your common table salt, sodium chloride. But there is a huge difference. Unlike table salt, diazonium salts are thermally unstable.
Now, this definition you see on screen is perfect for your exams. Look at the key phrases here. It says they are ionic, that's why they dissolve in water. Then it says thermally unstable, that is our core idea. And finally, releasing nitrogen gas. And that's the bubbling we were talking about. This gas is released when the salt breaks down or decomposes.
And this brings me to a very common misunderstanding. Many students see the word salt and they think, oh, okay, we can put it in a bottle and keep it on the shelf for a few months. No, that is completely wrong. Because they are so unstable, you have to prepare them fresh, you have to keep them cold, and you must use them immediately for the next step of your reaction.
Now, to make sure this idea of instability really sticks in your mind, I'm going to give you a powerful analogy. I know it's a bit dramatic, but trust me, it perfectly explains how these salts behave.
Yes, you heard that right. Imagine a grenade, but the safety pin has already been pulled out. It is stable enough that you can hold it for a very short time, but it is ready to go off. It's in a very high-energy, very unstable state, just waiting for the smallest trigger. Let's just break this down. The grenade itself represents the diazonium salt molecule. The fact that the pin is pulled means the salt is highly activated, it's ready to react. And what's the trigger? Well, it can be something as simple as a little bit of heat from the room. That extra thermal energy is enough to make it decompose, rapidly releasing nitrogen gas, which is basically the chemical version of the grenade exploding.
So let's try to build a clear mental picture of this decomposition. What does this explosion actually look like at a molecular level as we change the temperature? Let's just visualize it.
Okay, imagine you are in the lab. At 0 degrees Celsius, when the solution is in an ice bath, the molecules are vibrating quite slowly. The diazonium salt is, well, it's relatively stable. Now you take it out. As it warms up to room temperature, say 25 degrees, the vibrations of the molecules become faster. This extra energy starts to break the weak bonds, and you get slow decomposition. You'll see a few bubbles of nitrogen gas. But what if you heat it to 80 degrees? The vibrations become extremely vigorous. This causes the salt to break apart very rapidly, releasing a lot of nitrogen gas. You see the connection? More heat means more instability.
Now you might be thinking, okay, sir, this is interesting, but does it actually matter? Yes, it matters a lot. This property of thermal instability has huge practical consequences, especially in large-scale industrial manufacturing.
Take a look at this process. This is how azo dyes are made, the very dyes that give bright colors to our clothes. In the factory, they first prepare the diazonium salt solution, but look at step 2. This is the crucial part. They have to maintain the temperature strictly between 0 and 5 degrees Celsius. Why? To slow down the decomposition. This gives them a small window of time to add the next chemical, the coupling reagent. This is the molecule that needs to react with the diazonium salt to create the color. It's like a race against time. They need the desired reaction to happen before the diazonium salt just breaks down and disappears. So you see, temperature control is everything.
And just to really hammer this point home, let's go back to our table salt comparison. You might think that since both are ionic solids, they must be similar. And yes, both are ionic. But actually, when it comes to heat, they are complete opposites. NaCl is incredibly stable. Our N2 plus Cl minus is incredibly unstable. It starts to fall apart even at room temperature. One can be stored for years, the other, Well, you have to use it within minutes.
Okay, so we have covered quite a bit. Let's just quickly summarize everything into 3 simple points. These are the 3 things you must remember for your exam.
First, the core idea. Diazonium salts are ionic, but they are thermally unstable and decompose with heat, releasing nitrogen gas. Second, the analogy to help you remember. Think of them like a grenade with the pin pulled, ready to go off. And third, the real-world application. Because of this instability, we must keep them cold between 0 to 5 degrees Celsius and use them immediately. This is super important in industries like dye manufacturing.
And that's really all there is to it. The entire story of their physical properties is about that one central idea, instability. So if you can just remember the core idea, that grenade picture, and the real-world example of keeping them cold, I promise you this topic will feel much, much easier in your exam. Keep studying hard, and I will see you in the next explain.